Let us start with the previous video about the Hadoop distributed file system HDFS. For performance reason, name node stores all metadata in the memory. As I said that name node is the master node. So it should have all the necessary information to provide to the client. So all the information about the data and metadata must be stored in the memory of the name node. Upon startup, each node provides a block report to the name node. Once the system starts, each data node will be provided with a block report to the name node. The block reports are sent every 10 heartbeats. So this at every 10 heartbeats, one block report will be sent to the name node that data node is working fine. In almost all Hadoop deployments, there is a secondary name node while not explicitly required by a name node. It is highly recommendable. As I said that along with name node, a secondary name node will also be present in the system. It is actually not a failure recovery of the primary name node, but the secondary name node stores some important data which can be provided in case of primary name node fails. The term secondary name node is somewhat misleading. No need to get confused about the secondary name node. First of all, it should be clear that it is not a failure recovery of primary name node. It stores only some list information which can be provided to the system admin in case of the primary name node fails. It is not an active failure node and cannot replace the primary name node in case of its failure. The purpose of secondary name node is to perform periodic checkpoints that evaluate the status of the name node. It finds out it is used only to find the current status of the primary name node, whether it is working or not, or if any problem is there in the primary name node. I mentioned when HDFS writes a file, it is replicated across the cluster. So one file can be replicated on many data nodes among the clusters. This default value can be overruled with the HDFS DFS set rep command. So there is the command HDFS DFS set rep command which can be used to change the default value of the replicate. For Hadoop clusters containing more than 8 data nodes, the replication value is usually set to 3. If there are 8 or more than 8 data nodes in the cluster, then replication number will be 3. The HDFS default block size is often 64 MB. The block size is 4 KB or 8 KB. The HDFS default block size is often 64 MB. So generally, block size of the data will be 64 MB, but it can also be 4 MB, 4 KB or 8 KB. The HDFS default block size, not the minimum block size, however. If the 20 KB file is written in HDFS, it will create a block that is approximately 20 KB in the size. And if a file of 80 MB is written to HDFS, a 64 MB block and 16 MB block will be created. As I said that minimum size the default block size is 64 MB. So if you have a 80 MB of data, then 80 MB data will be first split up into 64 MB. Remaining block size is 16 MB. So here two blocks will be created. One is of 64 MB and another is of 16 MB. So here we can see that here a big one data is there of 64 MB. Now it will be divided here some data is there, so it is divided into 64 MB, 64 MB, 64, that is a default size. So first block, which is of 64 MB, it will be stored in the first data node, and replication of the first block will be stored in the here fourth data node, then here seventh data node. Similarly, the second block will be stored in the fourth block data node and fifth data node and sixth data node. So you can see that for every block there are 3 replication factors, and like that only in case of if any data node fails, suppose this data node fails, so first block can be recovered from this or this. Similarly, suppose in case of these 2 data node fails, then also the first block of the data can be recovered from this one, 7th one. Similarly, the second block is stored on 4th, 5th and 8th. In case of any one fails, it can be recovered from another data node. In case of 2 data node fails, then it can be recovered from the third data node. This is how it works. The above figure provides an example of how a file is broken into blocks and replicated across the cluster. In this case, a replication factor of 3 ensures that any one data node can fail and the replicated blocks will be available on other nodes and then subsequently re-replicated on other data node. As I said that for every block, you can say suppose block number 1, data block 1, its replication factor is 3. So 3 copy of each data block will be stored in the data node, like here 1, 2 and 3. Similarly, block number 2, data block 2, it is stored in 1, 2 and 3 node data. Similarly, data block 3, it is stored in first, second and third. So here each data block is there are 3 copy of each data block are created and they are stored in the data node. This is how it works. Now let us go to the HDFS safe mode. What do we mean by HDFS safe mode? So when a name node starts, it enters a read-only safe mode where blocks cannot be replicated or deleted. So safe mode of the name node is that mode in which only a read operation happens and there is no write operation or delete operation happens. You cannot change the data. So that is called the safe mode. So safe mode enables the name node to perform 2 important processes. First one, the previous file system state is reconstructed by loading the FS image file into memory and replaying the edit log. The previous file system, I mean whether what is the where it is written, how much it was read, that much all the previous state will be reconstructed by loading the FS image file into memory and replaying the edit log. The mapping between blocks and data nodes is created by waiting for enough of the data nodes to register so that at least one copy of the data is available. The mapping between blocks and data nodes is created by waiting for enough of the data nodes to register so that at least one copy of the data is available. So means